In this video, we're going to find out the structure of C9H10O using Proton NMR, and you'll find that this is an isomer of the structure that we produced in video 4. So let's get on with it. So we've got the NMR here. We have got, first of all, between 6 and 8, we can see we've got benzene, and it's mono-substituted because of the 5 here. There should be 6 carbons, 6 hydrogens on a benzene. There's not 6 hydrogens, it's 5, so it's mono-substituted. We've also got a quartet and a triplet with a 3 and a 2 relative peak area. That is characteristic of an ethyl group, and if you're not sure about that, you can go over video 1 in this series. So we've got an ethyl group and a benzene group. Now also, we've got an oxygen up here. So we know we haven't used up all our atoms. So an oxygen could be an alcohol. So look for an alcohol. Do you see a singlet with a 1 by it? No, so there's no alcohols. And then this also could be, for example, an aldehyde. That comes up between 9 and 10. There's no aldehyde peak, and therefore this is not an aldehyde, which kind of makes us think it might be a ketone. So let's do the table, and then you can see the chemical shifts. Again, the range for benzene is acceptable. You don't give an exact chemical shift. And then we do this peak splitting, and then the relative peak areas. Now, from that point, let's do the hydrogen environments, which is 3. So we've got 3 peaks, so 3 hydrogen environments, always good to say, and the n+1 rule for one of our peaks to make sure we understand this, and make sure in the exam, if it asks you to explain, you do include this n+1 rule. So quartet is n+1 equals 4. So 4 minus 1 is n, which is 3. So that means we have 3 hydrogens on the adjacent carbon. So the signal that gives the quartet, the hydrogens that give the quartet, have a set of hydrogens next to them which have 3 hydrogens on that carbon. And that means these 2 peaks must be next to each other. So that is a CH3 with a relative peak area of 3, and that is a CH2 with a relative peak area of 2. And they're next to each other because of this n+1 rule. Finishing off with our C6H5, which is our monosubstituted benzene. And then lastly, what we're going to do is look at what's left in this molecular formula. So here's our total molecular formula, and then let's take that down, and then you can see all of this added together means we've got a CO remaining, which again says we've probably got a ketone. Okay. So from that, let's move it all up, and let's start putting it together. So we know we've got a benzene. So let's do the benzene. That's bonded to something, we don't know what it is. And we know we've got a ethyl group. Okay, so we know we've got an ethyl group. And we know we're missing a CO. So it makes sense here. This CH2 here is going to be a quartet, because it's next to a carbon with 3 hydrogens on. This one here is going to be a triplet because it's next to a carbon with 2 hydrogens on. And this is going to be a multiplet. So if that is the case, I know there must be a carbon next to the CH2 with no hydrogens on it. Because it's got no hydrogens on it, it kind of makes sense. It's got to be that CO. Because it has to be that CO, because that has no hydrogens on. And if you bond this all together, you can see you've got your full complement. Now, if that is the case, the multiplet has a relative peak area of 5, quartet, 2, triplet, and 3. Now, if you look at that and you match it to this, all of that matches. Now, you can also do this with the data sheet. Okay, but sometimes the data sheet is confusing. I just want to show you that 2 things. One, how you can be totally unambiguous when you're doing the table, and 2, how you can use the data sheet as well. So you could have used the data sheet here, because if you look here on your data sheet, you'll see at 2.6, okay, is when a carbon with a hydrogen on it is bonded to a CO. Okay, so that gives a hint as well. So that will give a hint of that group using your data sheet. Also, if you want to make it completely unambiguous here, because that's the really important thing, that this is unambiguous, that they know that you know which carbon with which hydrogens gives rise to the signal. Often it's good to take a section out of this to show which one it is, especially if you have more than one CH2. So, for example, if I want to make this abundantly clear, I can take out this section here, which is the C double bond O. Okay, so our C double bond O and our CH2. So I'm just going to take that CO from there, okay, and I'm going to put it down. Okay, so you can see there I've put that CO down, okay, and it just tells me that CH2 is next to the CO. This CH2 is next to the CO, so it's totally unambiguous, and you will get your mark. Now, in this case, you would get your mark anyway, and that is because there's only one CH2 in the group, so therefore it wouldn't make any difference. But in more complex molecules, you might need to add a section of the molecule just to make sure that they know that that is the exact hydrogen that you meant. In this NMR, we have used the relative peak area to deduce how many substitutions there are, 5, because and we know it's mono-substituted, and we get this mess here with that 5 at the top. Now, once you've deduced a group, we used that to find out what was remaining, and then suggested that was a ketone, also by elimination of different functional groups, and looking at areas like aldehyde and alcohol. Also, we looked at an ethyl group and reminded ourselves of an ethyl group configuration that looks a bit like that. So it's really important that you take on board each one of these rules and use them in whatever one you face in the exam.